So for example number 6, we are given the equation y is equal to x squared. This is a piecewise function, and 2x. Now we're going to use x squared when x is less than or equal to 0, and when x is greater than 0, we'll use 2x. Now if I were to graph this, it would kind of look like this. Parabola up to this point, straight line with a slope of 2 up to that point. So that's kind of what my graph looks like. Now what they want us to do in example number 6 is to take the left-hand derivative and the right-hand derivative. Now if we were to go through this whole thing where we say the limit as h approaches 0, right? But we were to do it from the left-hand side of f of x, but it would be like f of x minus, or it'd be f of x plus h minus f of x all over h. And then we were to do the same thing from positive infinity, right? And we would say f of x, and I'm not going to go through because it's all written in your book. But if we were to go through that whole thing, what we have here on this end, we would have 0, and on this end we would end up with 2. And that makes sense, and we can tell that by looking at the curve of the graph. Actually, this is a parabola, and the vertex of the parabola occurs at 0, 0. And we know the slope from this is 2 because, well, it's a linear function, so the slope is 2. So if we come from this side, the slope's 2, but because this slope becomes less steep and less steep, in other words, if I take the tangent line here, and then the tangent line here, and then the tangent line here, at this point, the tangent line is equal to 0, if I come from the negative infinity direction. Right? But if I come from the right-hand side, the slope doesn't change, it's just 2. That's where that comes from. That's why Mr. Adams kind of skipped all that. Don't leave. Just let me explain that to you. So now what my question to you is this. What is the two-sided derivative at 0? What is the derivative? In other words, what's y prime evaluated at 0?
0.
Does not exist.
Okay.
Because the left-hand side doesn't equal the right-hand side. Okay?
Okay.
Now, before you guys leave,